Hello, ladies and gentlemen. So the first thing to talk about with MATLAB is why, as engineers, do we need to know it? And I want to explain that by showing this graph. That when you encounter the difficulty of an engineering problem versus how much time it takes to solve. And Excel is probably used by about 80% in 80% or so of the problems that you may encounter. Excel is very easy for easy problems, but very fast for easy problems. But for difficult problems, it gets a lot slower. MATLAB, on the other hand, harder to use than Excel, which is why people don't use it all the time. But it can do hard problems. It can do problems that are harder than Excel can handle. And then for really hard problems, big problems, you have your Java, C++, and so forth, Python, and so on. The really hard problems, this. MATLAB is in the middle. By the way, there is an alternative, New Octave. It runs MATLAB files. You don't have to make any modifications to run them in New Octave. It's open source. It's free. And its interface, it doesn't have the nice graphical user interface like MATLAB has. So beginning users sometimes struggle with New Octave until they really get to know how to write scripts and use the command line and things like that. A lot of beginning users struggle with New Octave. And of course, as a beginning user, you can spend $100, get a year's license for MATLAB on your student license, and then switch to New Octave later. Sometimes employers they balk when they look at the price of MATLAB. Excel, most of the time schools and Excel and employers will provide Excel as a tool for your job. Okay, there's Excel. Maybe 80% of the problems are handled by Excel. Of engineering problems, that is. This may be the other 19% can be handled by MATLAB or New Octave. And then the others, the last few, that really require big teams and a lot of work. Now, there is something called Mathematica, but what it does, Mathematica looks for a formula. MATLAB, New Octave, they're numerical. They do have symbolic processors that do a decent job, like Mathematica, and they do a pretty decent job, but their strength is in numerical. There is no formula for the period of a pendulum. There's an approximation. The formula that you get in school is an approximation, and you can extend that approximation to multiple terms. MATLAB, on the other hand, it'll do a numerical solution. It's got an ordinary differential equation solver, and you put in the expression, and it does a numerical solution. Not much work for you. It's a function that's built into MATLAB. Not much work for the engineer. Automatically takes care of this numerical simulation. And in engineering, a lot of times we're not looking for an exact answer. We're looking for an answer that's close enough. It reminds me of the difference between an engineer, scientist, and mathematician. So there's a room. Every time the whistle blows, you can cross half the distance to go across the room. On the other side of the room is your favorite beverage, wine, beer, or whatever. And the mathematician throws up their hands and says, you can't do it. You can never get there. Zeno's paradox. And the scientist says, well, you can get there with an arbitrary precision, epsilon. And the engineer starts going and says, you can get close enough. So engineering is the close enough profession. MATLAB is just like the tool that engineers have gravitated to as far as a good analytical tool that's pretty easy to use, not as hard as Mathematica, and does the job that engineers need. So that's why we use Mathematica. Software engineers, of course, will be up here. They have a different class of problems. You want to pick the right tool for the right problem. That's kind of the message here. For most other engineers, other than software engineers, for everybody else in the engineering profession, this is the one that can do some powerful stuff if you need to go beyond Excel. Okay, that's all, folks, for this video. Check out my next one where you actually get to figure out how to use MATLAB.